Okay, we're going to continue on with Chapter 9 on rational expressions. So today we're looking at Section 9.2, where we multiply and divide rational expressions. So when we multiply rational expressions, it's in the same manner as when we multiply fractions. Basically, we're going to divide out common factors along the way before we multiply everything together to keep it simpler, because otherwise we'll have to reduce at the very end. And if we can reduce before, that makes life easier. So what we do is we're going to do the same thing as I said with fractions. We're going to basically reduce these to the prime factors. So 20 is going to be 5 times 2 times 2. 18 is 3 times 3 times 2. 21 is 7 times 3, and then 50 is 5 times 5 times 2. And then we get to have fun and cancel everything out. And after we do that, all we have is 7 left in the numerator and 15 left in the denominator. And so that's exactly how we're going to do the polynomials with the rational expressions. We have to factor them, cancel everything out, and then we can multiply them. Although when we get done, we're not going to actually multiply them and have them back into an x squared form. We're going to leave them as factors. That way we show that there's nothing else we can reduce. So again, when we multiply or divide polynomials, we first factor them like we did here with the prime factorization, and then cancel out everything, and then we leave it as our fractions. Now remember, when we divide, it's not the same as multiplying. What we do is we keep the first fraction the same, switch it to multiply, and then take the reciprocal of the second rational expression. And so that's how we're going to do those. And so really what we're going to do is we're just going to jump in and start working on simplifying the expressions. And so on these first couple, they have them factored for us or in a format where we can do them simply and all we have to do is cancel. And so, well, here we have n can cancel n. Nothing else can cancel. Now, since they're numbers, what I'm going to go ahead and do is I'm going to multiply the numbers together. So 9 times 7, that'll give me 63. And 2 times 5 is 10, and then it still times n. And so that would be my simplified expression, because I wouldn't keep the numbers not multiplied together. I'd go ahead and multiply those. I just wouldn't multiply things like m minus 6 times 7m minus 5. I would leave that out if it didn't cancel. Now, so then for the next one, what can we do? Well, if we look at that, there's a lot of things that can cancel. We can have 7 cancels 7, m minus 6 cancels m minus 6, 7m minus 5 cancels 7m minus 5, and we're left with just that 5m. And so that whole thing simplifies to 5m. And that's what's going to happen a lot of times on our problems. It's going to have some complex thing we have to factor out, 4 trinomials, and when we get done, we might have a binomial or a binomial over a binomial, so something simple. And so that's a nice thing. If you're having troubles factoring one trinomial, look and see if anything can cancel, kind of like we saw in the first one, to make it simpler to factor these. Now this one, number 3, if we look at it, it's really not too complex because all we can do is factor out a GCF here, factor out a GCF here, and then after that it looks like all we can do is reduce. So if we factor out that 25, what do we have left over? Well, we have n minus 1. Now that's just over 5, so we're just going to leave it over 5. Now the 4, we're not going to reduce down, we're just going to leave it as a 4. And then now the next one, it looks like a GCF is 30, so then that gives us n plus 1. And now at this stage, we can start canceling things that will work. Well, 5 will go in here once, and it'll go in here 5 times. Well, here, 5 will go in, well, let's go ahead. Well, 5 will go in here once, and it'll go in here 6 times. Now 2 will go in here twice, 2 will go in here 3 times. So now those are opposite signs, so that's all we can do. So we have on the numerator n minus 1 times 2, so 2 times n minus 1. In the denominator, it's 3 times n plus 1. And then that's our final reduced form. So we multiply these two rational expressions together, and this is the rational expression that we get out when we're done. Now what about the next one? Well, the next one, we have x plus 5, x plus 5, x minus 7, and this part here, this trinomial, is the only thing it looks like we have to try to factor. So when I factor that, I'm going to take into consideration, I have an x minus 7 here. It might actually be what I need to have here. So then what does that give me here? Well, what times 7 is, it's going to be a 1, and we have to have opposite signs, so it has to be plus. So does that give me that trinomial? X squared. Then we have plus 1x minus 7x, so it's going to be minus 6x and then minus 7. So that looks good. And we have x plus 5 times, and we have x plus 5 over x minus 7. All right, now we get a cancel everything we factored. So x minus 7, x plus 5, and we're left with just x plus 1. And so that's going to be our final value. And, you know, we had a trinomial over a binomial and then a binomial over a binomial, and we end up with just a binomial. All right, moving on to the next one. Here we have, it looks like only GCFs that we can cancel out here, or factor out, I should say. So in the numerator, it looks like we can pull out that 3. And what do we have left over? X minus 2. Now down here, it looks like a 12 is common, so we can pull out a 12, and what's left over is x minus 2. Haha, there's something we can cancel. And then we have x plus 3. Now I'm going to go ahead and put that over 1, so I kind of remember that it's over 1. Now what can we do? Well, the x minus 2 cancels x minus 2. And now 3 will go in here once. 3 will go in here 4 times. And now nothing else will cancel. So what does that give me then? Well, that gives me x plus 3 over 4. And that's my final rational expression after multiplying those two items together. All right, so now I have a binomial over binomial and then a binomial over trinomial. Well, that first one, n minus 7, nothing can be factored out, so I'll leave it alone. Now here, I'm starting to see that, you know, these, if I rewrite this as minus 6n plus 12, I have opposite signs. So what I'm going to go ahead and do is I'm going to pull out the GCF here, and that's going to be n minus 2. But now to make this so I have a factor of n minus 2, I'm going to pull out a negative 6. Because if I pull out a negative 6, what do I have? Well, I have an n, becomes positive, and then minus 2. So minus 6n plus 12, and that's what I have here. And so sometimes you have to kind of look ahead and see things that might be similar but maybe opposite signs, and that'll make your life easier. Otherwise, you would have maybe pulled out a 6, then you would have 2 minus n, and looking at that, you know, you say, oh, that doesn't cancel. But when you take out the negative, it does cancel. Now, what do we have? Now we have a trinomial that we have to factor. So that's going to be an n and an n. Now they're both going to be minus because we have to have a minus in the middle, and this is a plus. And now two factors of 42 that add to 13, well, that would be 6 and 7. Now I think I have everything factored as much as possible. So it looks like n minus 7, n minus 7. Now here I have n minus 2, n minus 2. Now here, one of those cancels there, and I have a minus 1 still here. So now that's as far as I can cancel out. And so now I've made this equal to a negative 1 over n minus 6. And so that big set of two rational expressions has reduced to a minus 1 over an n minus 6. All right, so now we have 4 trinomials, or 2 trinomials and 2 binomials, I guess. I'm looking on the right side there. So we have a lot of stuff to factor, it appears. So on this one, I'm going to have 2 factors of 32 that add to 12. Well, it's going to both be negative, so I'm going to have x minus 8, x minus 4. 8 times 4 is 32, 8 plus 4 is 12, and so that's going to be my factorization of that. Now on this one, that one's going to be a little different. So I'll have an x and I'll have an x. One's going to be a plus, one's going to be a minus. And so 2 factors of 16 that add to a negative 6 after we subtract them, basically. And because we have to have a minus and a plus, and so the larger one has to be negative. Well, 2 times 8 is 16, and 8 minus 2 is 6. So if I have a negative 8 and a plus 2, that should give it to me. And if I looked up here, I have a negative 8, so that would have been probably a good guess to start with, but I didn't look at that right away. Now here it looks like we have a GCF. That's all we can do. We can pull out a 7x. Now if we do that, we're left with x plus 2. All right, what about here? Well, again, it looks like I have a 7x I can pull out. And what's left is going to be x plus 3. Now we get to have fun and cancel stuff out. So what do we have? Well, we know that x minus 8 cancels. X plus 2 over here cancels. 7x cancels. And we're just left with the x minus 4 over x plus 3. And so that's our final rational expression after multiplying these two rational expressions together. So it makes it much simpler looking. If you multiplied all that together and got numbers, it would be very complex. But when you get done, it really is pretty simple if you do the factoring first. Aha, notice here we have a division. So our first one with division, so we have to remember to multiply by the reciprocal. So 8k, well, we can't do anything with that. Now here we see, oops, I think if I remember right, that was supposed to be a k there. I forgot to fix that in the thing, but I remember that that was a k when I was looking through it, and then apparently when I saved it, it didn't save in there. All right, so I have to pull out 8k again. And so that leaves me with a 3k, and then that's going to be minus 5. Okay. And now I have to change it to multiply, and I'm going to multiply by the reciprocal. So this goes to the top. So what do I have here? Well, I have a 5 I can pull out, and it's left 3k minus 5, and then over 1. Now you can see why I remembered that was a k there, because things cancel when we do that. Oops, we want a red. So 8k will cancel 8k, 3k minus 5 cancels 3k minus 5, and we're left with a simple old 5, okay? And so again, like I said, sometimes you end up with really simple answers when the problem looks actually pretty complex. All right, another one where we have a division, and if we look down below, so is that one. So what we need to do is go ahead and factor our numerator, and then, well, the denominator we can't factor, but we can factor that numerator. So if we look at that numerator, what we have is, it looks like a 7r and an r. And do I want to go ahead and say it's a plus 2? I'm not going to yet, because that might not be the right way with 24 here. So then let's go ahead and put this over our 7r plus 2. I'm going to factor these instead, because that might help me with that. So remember, we change it to multiply, and then we do the reciprocal. So what was in the numerator comes down to the denominator, and what was in the denominator goes to the numerator. So this looks like there's a 7 in the common, and what's left over is 7r plus 2. Now here, this looks like there's a 7 also in common, and that leaves 7r plus 3. So now, because that 7r plus 2 cancels there, I'm going to assume that's going to be a plus 3. And what does that mean this has to be? That has to be a minus 8. Now let's check to make sure it gives us our original value back. Well, that's 7r squared. Then we have minus 56r plus 3r, so that's minus 53r, and then minus 24. So that looks good. And again, factor things that are easier first, and then other things sometimes come out really nice. So our 7r plus 2 and 7r plus 2, well, 7 and 7 there. Then we have 7r plus 3, 7r plus 3, and we're left with just r minus 8. So very simple little binomial left after a complex division of two rational expressions. All right, so the next one, again, we have to remember to multiply by the reciprocal. So on the first one, well, I'm going to pull out a 2 first, and then I can do the factoring a little bit. If I do that, that's going to be n squared minus 6n minus, and that's going to be 27. Okay, well, if I do this, that's going to be 2 times n plus 3. All right, so let's rewrite this now. Now, this is going to be 2 times, and now we have to factor that trinomial. And then n plus 7, so that we can't change. And we're going to multiply by the reciprocal. So this was in the numerator, so now it's in the denominator. And then 1 was in the denominator, so now that's in the, whoa, that was weird. That was now going to be in the numerator, so let's erase that, make it a 1, not a squiggle. And so now I'm going to assume, hey, you know, I have n plus 3 here, so let's see if I put an n plus 3 here, what will this have to be? Well, that's going to have to be an n, and then 3 times what? Well, 9. It's going to have to be a negative. So now does that give me what this is? Well, that's going to be n squared minus 9n plus 3n, so it's going to be minus 6n. That gives me that, and then minus 27. So that looks good. And so now I get to have the fun of canceling. Well, 2 cancels 2, n plus 3 cancels n plus 3, and now I'm left with a binomial over a binomial. And so it gives me n minus 9 over n plus 7. Okay. So again, you know, when I got the 2 out, you know, I still had something and it's like, well, you know, I don't know exactly. So let's do something simpler over here. I got that, and then I tried that n plus 3 here, and that was easily gave me the next one. So, you know, doing easier factoring first, and then your harder ones sometimes become really easy. All right, so here we have a couple of things to factor, it looks like. So our first one, 2 factors of 24 that add to 11, well, that would be 3 and 8. So if we have x plus 3, x plus 8, that should give me my numerator. Now the denominator, it looks like I have a GCF of 6x squared, and then I'm left with x plus 3. Now we're back to multiply, so we can just take that here. And if I pull out another 6x squared, I'm left with x plus 1. And down here, it looks like I've got difference, and the larger one has to be positive. And so I'm going to have x plus 8x minus 3 to get the 24 negative. And then 8 minus 3 is 5, so that looks good. So now I can just start canceling again. All right, so 6x squared and 6x squared, x plus 8, x plus 8, x plus 3, x plus 3, and then that's what I'm left with. So I'm left with just x plus 1 over x minus 3. Okay, and so the complex multiplication of 2 rational expressions comes down to a rational expression with a binomial over a binomial. All right, here again, we have to remember, we have to multiply by the reciprocal. All right, so the first thing I'm going to do is, okay, one thing I notice here, I have the same thing here and the same thing here. Now remember, I'm multiplying by the reciprocal, so this is going to go to the numerator when I have it, and so I'm not even going to factor those because they're going to cancel out. So really, all I have to factor is the numerator here, the denominator, that looks like it's going to cancel out, and then multiply by the reciprocal, which is 49x squared plus 7x minus 72 over, and then I'll have to factor this one as well. So those two cancel, so I don't have to factor those. So now I look at this one, and I'm going to have, well, I'm going to have a 7x and an x, and it's going to be a minus and a minus. And now maybe, let's see, 10 and an 8 would be my obvious choice because I see that both of these have something like a 10 in them. So maybe I'll have, if I have a 10 here and an 8 here, that's minus 56 minus 10, so it's minus 66. And so then I'm going to assume that's going to be a 7x minus 10 here. And then what's left over is going to be an x, and then it's going to be a plus 7. Now, does that work? 7x squared, then I have 49x minus 10x is 39x, and minus 70. All right, so that looks like we have everything factored. So those two are gone. 7x minus 10 is gone, and I just have those two binomials left, which is x minus 8 over x plus 7. All right, so there is where I have finished, and I had those three trinomials to factor, and I only really factored two of them because those two canceled out and I didn't have to worry about them. So looking ahead sometimes helps you so you don't actually have to do some work. All right, now we have three rational expressions, and the last one is a division. So what I'm going to do is I'm just going to go below and then remember to make that a multiply by the reciprocal. Notice here, remember, this is x cubed minus 3 cubed, because 3 times 3 is 9 times 3 is 27. So we have a difference of cubes, so we have to remember how to factor that. This is a difference of squares, so I have to remember how to factor that. Those are special cases. And so let's start. All right, so the first one, x squared, okay, so they both have to be plus two factors of 9 to add to 3. Well, that's not possible. So that's irreducible, non-factorable, however you want to look at it. And so I'm just going to rewrite it here. And if I remember my difference of cubes, I think that might be taken care of at that spot there. And here I have two factors of 12 that subtract to 1. Well, that would be x plus 4, x minus 3. So that's x squared plus 4x minus 3x is x, and then minus 12. Now here I'm going to have x, and I'm going to have plus and a minus, and two factors of 8 that go to 2. So the larger one's 4, the smaller one's 2. 4 minus 2 is positive. It works there. Now, remember that the first term when you do the difference of cubes is going to be just the x minus a, whichever that is, and that's in this case 3, times x squared, then change the sign to a plus, and then 3 times x, plus then the last one squared, which is 9. So that's where that cancels, so yay. Now change to multiply by the reciprocal, so now this has to go to the numerator, and that can be factored. And it's going to be opposite, both of them negative, so it's going to be x minus 3, x minus 3, so that's a perfect trinomial, so it's going to be just factored in like that. And the other one is a difference of squares, so if you remember that, that's going to be x plus 2, x minus 2. And now I have everything factored, and now I just have to cancel stuff out. Well, the best part is canceling those. And now we just kind of go down the row, x plus 4, x plus 4. Here's an x minus 3, x minus 3. Here's an x minus 2, x minus 2. Here's an x minus 3, here's an x minus 3. And so we've canceled everything but that x plus 2. So our final answer is just 1 over x plus 2. So this complex thing simplifies to just the 1 over x plus 2. All right, so another one similar, two multiplication, or a multiplication of two rational expressions followed by a division. And so what do we have to do? Well, we have to factor. And so the first one, and so what factors of 10 add or subtract to 3? Well, it's going to be x plus 5, x minus 2. 5 minus 2 is 3. Over, now those, it's just going to be x plus 5, x plus 1, and times. Now here we'll have a 2x and an x. And now we have to subtract, so we have to have larger minus a smaller gives us that one. So we have a 3 and a 1. So if we have a 3 here and a 1 here, the larger one has to be negative, the other one positive, so that's 2x squared. Now we have 2x minus 3x, so it's going to be minus x, then minus 3, so that looks good. Now here, 2x and x again. Now let's see if we put a minus 3 here, and then what's going to have to be here? Well, it's going to have to be a plus 2. Now does that work? That's 2x squared. Then we have plus 4x minus 3x is going to be plus x. and minus 6, so that looks good. Remember, multiply by the reciprocal. And so here, this is going to go to the numerator, so it looks like it has a GCF of 3. So it gives us 2x plus 5. Now this goes to the denominator. It looks like it's a GCF of 4, and that's also going to be 2x plus 5. All right, so now what we have to do is we have to cancel everything out. Well, x plus 5, 2x minus 3, 2x minus 3, 2x plus 5, 2x plus 5. Those are the easy ones. Now we have x plus 1, x plus 1. Now that doesn't cancel that, and those don't cancel those. And so what we end up with is 3 times x minus 2 over 4 times x plus 2. And again, we're going to leave it in the factored form so we don't have to worry about anything. And that shows that nothing can be canceled. All right. Now we have to perform the indicated operations and simplify. So now we have to remember what we have here. Now, I believe I have a typo here, and these aren't P and R because those are F and G. So what we have to do is we have to switch these to F and G. So what we actually have is F dot G of X, and if you remember, that is really just F of X times G of X, and I bet the next one is going to be the same way because I think I copied pieces, and yep, we're going to have to change that one too, but that's okay. All right, so what do we have here? We're just going to take basically our f of x they give us times the g of x they give us, and we just have to factor and simplify. So let's rewrite it as the whole thing, 5x squared plus 8x plus 3 over 5x squared plus 7x plus 2 times x squared minus 4x plus 3 over 5x squared minus 2x and then minus 3. All right. What do we need to do now? Well, what we have to do is factor. So I'm just going to do it below because it's going to be easier to see. So I'll have a 5x and x and a 3 and a 1. And if we put a 3 here and a 1 here, plus and a plus, that's going to be 5x plus 3x is 8x and then 3. So that looks good. Now I'm betting this one's not going to be a 5 and a 3. This is going to be a 5x plus 2 and x plus 1. That'll give me a 5x plus 2x is 7x. All right, so now we multiply by. Now we'll have x minus 3 and x minus 1. Does that give me that? Because we have two negatives make a positive, and added together they're going to be negative. So it's negative 3x minus x is minus 4x. So that looks good. And so now I'm betting one of these is going to be a 5x plus 3. And then we have an x minus 1. Now, does that give me what I want? Minus 5x plus 3x is minus 2x. So, yep, it does. Now we cancel. So 5x plus 3, x plus 1, x minus 1, and now we just have x minus 3 over 5x plus 2. Okay, so that's all we have to do. Now the next one, again, I just copied straight out of the book and I didn't pay attention, but now I see this should be the f and this should be the g, and so we're taking f divided by g of x, and so really we're taking f of x divided by g of x instead of p and r. And so what we do is we're going to replace these and say that's 3x squared minus 10x plus 8 over 3x squared minus 4x minus 4 divided by, and now we have 3x squared plus 8x minus 16 over x squared plus 5x plus 4. All right, so when we're going to do this, we're going to have to factor all these. We're changed to multiply by the reciprocal. Well, that one's going to be the easiest one to factor, so I'll go ahead and do it first. That's x plus 5x plus 1, or 4, sorry. I saw a 5 when I was writing, and so I put a 5. So that gives me 4x plus 1x is 5x. And so now maybe, I don't know which is easiest. We'll just do the other one so I remember to put it in the denominator. So that's going to be a 3x and x. And if we do a 4 and a 4, that's going to be 1's plus, 1's minus. I need a plus 8. So that's going to be a plus 4 and a minus 4. So that'll be 12 minus 4 is 8. So that has that one factored. Now this one, I know both of them are going to be negative, and I need to add to 10, and I'm going to cheat, and I'm going to say, well, that's going to be 3x minus 4, and what's left over is x minus 2 to get the 8, so let's check it. 3x squared, and then we have minus 6 minus 4, that's minus 10, plus 8, so it looks good. And down here, I'm going to have a 3x, and I'm going to have an x, and I have to get a 4. If I do a 2 and a 2, I'll have a 6 and a minus 2 is going to be a 4, and I need it to be a negative, so that has to be negative. That one has to be positive. And so now I think I have everything done, so let's cancel. All right, well, x minus 2, 3x minus 4, 3x minus 4, x plus 4, x plus 4. Now I just have x plus 1 over the 3x plus 2. And so that then is going to be my final answer for the f of x divided by the g of x. And that's all I have for this section.